going on, everybody? In this video I want to talk about the procedure that we use to solve rational equations. In other words, the procedure that we use to solve equations that have roots in them. So I'm going to walk you through the process of that. So let's say that I have the equation 2x plus 3 plus the square root of x minus 2, let's do minus 2, is equal to 2. So the first thing that I'm going to need to do is I'm going to get one of the roots isolated. So what I'm going to do is I'm going to subtract the square root of x minus 2 on either side. So what I end up with is the square root of 2x plus 3 is equal to 2 minus the square root of x minus 2. And then, because I have one of the roots isolated, what I can do is I can raise both sides to the second power, just like that. And then when I do that, the root and the power over here cancel, and I'm left with 2x plus 3 on the left hand side of the equation. And on the right hand side, I have binomial expansion. So this is 4 minus 4 times the square root of x minus 2 plus x minus 2, because the square root of x minus 2 squared is just x minus 2. So now I'm going to clean this up a little bit and simplify by combining like terms on the right side. So I have 2x plus 3 is equal. So I have 4 minus 2, which gives me a 2 minus 4 times the square root of x minus 2. And then I have a plus x. And then what I need to do is I need to isolate this square root to get it by itself. So I'm going to do that by subtracting them both from either side. So I have x plus 1 is equal to minus 4 times the square root of x minus 2. And so now we are in a position to where we can square both sides. And what that allows us to do is to cancel out the root that we have remaining. So on the left hand side we have another binomial expansion. So this is going to be x squared plus 2x plus 1. And then you set that equal to 16 times x minus 2, because remember, the exponent gets distributed to terms that are multiplied together. And so I'm going to distribute on the right hand side. So I have x squared plus 2x plus 1 is equal to 16x minus 32. And then what I'm going to do now is move each of the terms to the other side of the equation. So finally I have x squared minus 14x plus 33 is equal to 0. And then now we have it in the form of a quadratic equation. So this one you can solve by factoring, and the factor pairs are going to be x minus 3 times x minus 11. And so we have the solutions x minus 3 is equal to 0 and x minus 11 is equal to 0, meaning that x is equal to 3 and x is equal to 11. So for these particular types of equations, we're not really done yet, because we need to check and see if the answers that we get are valid in the domain. And sometimes whenever you have square roots, since you are squaring, you need to take into account positive and negative, so we might have extraneous solutions here. So what I'm going to do is I'm going to take each of the x values that I have and plug them back into the original equation and see if it works out. So for the first one, I have the square root of 2 times 3 plus 3 plus the square root of 3 minus 2. So 2 times 3 is 6, and 6 plus 3 is 9, so I have the square root of 9. And 3 minus 2 is 1, so I have the square root of 1. Square root of 9 is 3, and the square root of 1 is 1. And this equals 4, which is not equal to 2. So what this tells us is that the solution x is equal to 3 is extraneous. So now I'm going to go ahead and check the other solution, x is equal to 11. So I have 2 times 11 plus 3 plus the square root of 11 minus 2. So this is going to be the square root of 25 plus the square root of 9, which is 5 plus 3, which is not 2 also. So that tells us that both of the solutions that we have are extraneous. So even though we were able to solve for x, neither of them are actually solutions, because when you plug them back in, they don't produce a true statement. So the answer is that this equation has no solution. we have 5 times the square root of x minus the square root of x minus 1 is equal to 6. So like the last example, the first thing that I'm going to do is isolate one of the square roots. So I'm going to try to isolate the middle term by switching the 6 and the square root of x minus 1, switching them on either side of the equal sign. So what I have is I have 5 times the square root of x minus 6 is equal to the square root of x minus 1. And when I do that, I am able to square both sides of the equation so that I can cancel the root on the right hand side. And what I end up with is I have 25 times x minus 60 times the square root of x plus 36. And this is equal to x minus 1. And so again, I'm going to take this middle term and isolate it by subtracting 25x and 36 on either side. And when I do that, I'm left with minus 60 times the square root of x is equal to minus 24x minus 37. And so now I'm in a good position to square both sides again, since I have the term with the root in it isolated. So I'm going to square both sides. And what this ends up giving me is a 3600 times x is equal to 576x squared minus plus a 1776x plus 1369. And so the last thing that I need to do is transfer the 3600x over to the other side. So I have 576x squared minus 1824x plus 1369 is equal to 0. So we have our equation in the form of a quadratic. However, the coefficients are really large, so it's most efficient to just plug these numbers into the quadratic formula. And so whenever I do that, I have x is equal to 1824 plus or minus the square root of 1824 squared minus 4. A is 576 and C is 1369. And all of this is divided by 2 times 576. And so what I get from my answers is that x is around 1.94. I'll round it to 3 decimals. And I also have x is around 1.222. So these are the two answers that I have to plug into the original equation to see if it works. Now these are approximate solutions, so if I have something that's close to 6, then I will accept these as good answers. So what I have is I have 5 times the square root of 1.944 minus the square root of 1.944 minus 1. And when I plug this answer into the calculator, I get an answer very close to 6. So this answer checks out. And then for the second answer, I have 5 times the square root of 1.222 minus the square root of 1.222 minus 1. And then when I plug this into the calculator, I get an answer of around 5.06, which is not close enough to 6 for me to justify this as correct. So I have one correct answer and one extraneous solution. So I hope you guys enjoyed this video on how we solve radical equations. So the whole idea is to get the terms with the radicals with them isolated so that you can square both sides, and then eventually you can manipulate the equation into something that's a bit more familiar, like a quadratic equation, and then you can solve the quadratic equation that results from your algebra. So I hope this video was helpful. Thank you guys for watching, and stay tuned for the next one. Take care, everybody.